it's Mrs. Poole.
And Mrs. Weeks, we're back again.
Hey, and we're going to talk about mixed numbers and improper fractions
That's
today.
right. And we started a little bit in class, so it's great for you guys to hear this all again. And we have a couple of questions at the very end of the video that you'll have to do for us and bring back to class. But we thought we'd start today looking at pieces, and these should be equal pieces of a whole. So I have we're going to call these for candy bars.
Yeah, you know, sometimes just this time of the day, we're always hungry, so it's always about food.
Yes, it really
always
is.
about food.
Once again, you can always bring your food to Mrs. Poole or Mrs. Weeks.
Anytime you want to bring proof, we'll take it.
Exactly. All right, so we're going to call these candy bars, and what do you want to do with these candy bars? I actually have already sort of cut them in pieces, haven't I?
You've got them in pieces,
Okay.
and it looks like each piece is 4, or each candy bar has 4 pieces. And we have 3 different people who are eating these candy bars?
Yes, yes.
And I think the first person eats 2/4.
Okay.
I think that's what I see here.
Okay,
So
all
2/4. So 2 out of 4 pieces.
Okay, so let me color that in so we know that's been eaten. Okay, this piece.
Billy Bob ate 2/4.
That's right. Okay, so this represents 2/4 of that eaten. Okay, so what about this next one right here? And what do you think? I wanted to get my little light up guy, but I can't seem to find him. Okay, here we go. Here we go. I think that's him. Okay, what about this candy bar right here?
Ooh, that candy bar. Susie was a little bit hungrier than Billy Bob, and she ate 3/4 of her candy bar.
All right, here we go. 1/4, 2/4, 3/4. Okay.
And you know, if you put those two together, we would have...
looks like we already have more than a whole.
1, 2, 3, 4, 5/4.
That's right. So we already have more than a whole, don't we?
More than a whole.
Okay, all right. What about this last one? What do we think about that? Is that...
Oh, she was super hungry at the end of the day. She ate 4/4 of her candy bar.
Ooh.
Or we know that 4/4, anytime that we have a denominator and a numerator that are the same, it equals one
whole.
Yay!
Okay, now we need to look at these because basically our question is how many fourths were eaten. So we need to go through and count all these and see how many fourths there are, because I bet anything we have more than, well, we know we probably have more than a whole because this one represents a whole right here.
That is a whole.
So this is 1, 2, 3, 4, and then we'll go hop back over here to this one, 5, 6, 7, 8, 9. So we actually have what looks like to be 9. And then what is our denominator, Miss Poole? Because we do seem to get confused about that.
We do, but we are working with fourths, so we have 9/4.
Okay,
because
all right.
each candy bar was broken up into 4 pieces.
Okay, but not 12, right? It's not 9/12. No, because this doesn't represent 12ths. Each of these pieces actually represents a fourth. So there were 9/4 there colored in. Okay,
right.
This is kind of an ugly looking fraction though, isn't it? Do we
It
call those by something?
is. Those are those improper fractions because we have a bigger numerator than we do a denominator.
Very nice.
Meaning that we have more than one
whole. Very good job. As a matter of fact, what is the one whole that we could take out of this one right here? What would we take out?
We can take 4/4 out.
Right, and that would represent one whole, wouldn't it? So if we had 4/4, that actually would be a whole.
Actually, we could take out another 4/4, Mrs. Weeks.
That's right, exactly. So there's more than just one whole living in there. There's actually
2 wholes.
That's right. A couple of ways to look at this. Just like we said, we would take 4/4 out of there. When we did that, we'd be left with 5/4. We could take another 4/4 out of there, so then we know we have 2 wholes, and there would be 1 left over. That, or we always need to look at this line because in years to come, everybody will need to know that that line actually represents division. So we could ask ourselves, how many times does 4 go into 9? And we would know what?
2.
It would be 2 times, and how many would be left over?
We would have 1 left over because 2 times 4 is 8. Plus 1 more is 9.
So this becomes 2 and 1/4 because we don't change our denominator at all. And this is what the mixed number would look like for 9/4. Very nice job.
Very nice.
All right. Well, why don't we look at something where
Let's see if we can go backwards from a
here.
mixed number to a improper fraction.
Yep. Okay.
What do you know about that, Mrs. Weeks?
Well, you know what? This is kind of tricky, but we have a little saying that we've said here in 4th and 5th grade, and some of them may have shared that with you today.
They did share it
They
with me
did.
today, and I was quite confused at first, but then I picked up on it.
I love that they shared it with you, though.
Uh-huh.
See, we say over the railroad tracks, so I'm going to try to do this way, and then past the hospital is basically what we say.
Yes.
So that X kind of looks like a railroad crossing sign, I guess.
I guess so.
And then the plus sign looks more like, I guess, a hospital Red Cross
The
sign.
Red Cross. You know, whatever it takes, right?
That's right.
Whatever it takes.
This is the little saying that they've had last year and this year, so we'll stick with it. As long as you understand that you are moving in this direction is basically it. So in order to convert this mixed number back to an improper fraction, we would do the 5 times 2, which is 10, and then plus 3, which would be 13 fifths.
And we still stay with that same denominator.
That's right, exactly. That does not change. I don't know how many times I say that. That does not change.
That does not change.
It does not. How about we try one more so you guys can do this? So 3.
So really, when we are multiplying there, we're saying that we have 2 groups of fifths, right?
That's right, exactly.
So,
that's exactly what you
meaning
would
that
have
we have
seen.
2 holes.
Exactly. 2 holes that represented 5/5, and then we had that additional portion, that fraction part left that represented 3 out of the 5, which we have to add back in so your picture would look like that. So, all right, well, what about this one? So let's give this one a whirly-dirl.
All right.
And again, we'll put in our little times and our plus just so we remember. But so how many groups of 9/9 were there?
There were 3 groups of
There
9
you
ninths.
go. And that's where we get the 9 times 3, which is 27. Plus 4 more
is 31 ninths.
There you go. Beautiful job. And there's our improper
Yay!
fraction. All right, guys. So now,
Turn.
your turn. We have 14/6, which we want you to turn into a mixed number with a picture. And then 3 2/5, which we want you to turn into an improper fraction with a picture.
Those pictures always help just to prove your answer, don't they? I mean,
Very good job. We say that all the time. You need to prove that
Yes.
as those answers in math, don't you?
Well, have fun with your improper fraction.
And mixed numbers.